Morning, students. So yesterday we have discussed about that current electricity Wheatstone bridge balancing condition, right? So today also we'll discuss one more important topic related to your LAQ from nuclei chapter. From nuclei chapter. So what is that nuclei chapter means? From that nuclei chapter, one of the important topic which is comes for LAQ is working of nuclear reactor. What is nuclear reactor and how it's work? And we need to explain the different parts of nuclear reactor. Clear? See, what is that you see here? From nuclei chapter, LAQ. Question is, state the principle of nuclear reactor and explain its working. With neat diagram. State the principle of nuclear reactor and explain its working with a neat diagram. That is what question. And this is LAQ, long answer type of question. So in this one, basically, two parts are there again. One is statement of the principle. State the principle of nuclear reactor. What is the principle of nuclear reactor? We need to say, and we need to explain the working of nuclear reactor with a neat labeled diagram. So what is a nuclear reactor basically? A nuclear reactor is a device which is used to produce electricity, produce electric power or electricity, we can say. How it can produce? Because you know that we have different power plants are there which are able to produce electrical power. Hydel power plants, windmills, thermal power plants, like the different power plants we have. In different thermal plants, different power plant, we will use different input energy to convert into electrical energy or to able to produce electrical power. So in general, in that one of that nuclear power plant, by using a nuclear energy, we can produce electrical power by using a device called nuclear reactor. So this is the device which used to produce electrical power by using nuclear energy. But how the nuclear energy will produce means nuclear energy can produce by using nuclear reaction. Nuclear reaction, that is only nuclear fission reaction. Nuclear fission reaction. What is mean by nuclear fission reaction means there is heavy nucleus split up into two or more lighter nucleus, and heavy nucleus bombard with a neutron. So that heavy nucleus which are split up into two or more lighter nucleus, that is heavy nucleus breaks into lighter nucleus, called nuclear fission reaction. So each nuclear fission reaction, certain amount of energy will be released. That energy only we call nuclear fission energy, or simply nuclear energy we can say. And by using that nuclear fission energy, we will generally that nuclear energy in the form of heat will be generated, and that will heat used to develop a steam by using a water. Develop a steam by using a water, and this steam which is generated by using a nuclear fission energy, okay, is allowed, that steam is allowed to fall on the turbines. Basically, heard about the turbine. Every power plant, the common term called turbine. So turbine, what it will do means, the turbines on the turbine in this nuclear reactor, the steam, the fast moving steam is allowed to fall on the turbines. And this steam turbine, due to falling on the turbines, the turbine will rotate. And this turbine will rotate. Rotation of the turbine is able to produce the electrical power. Then that is different again principle, how the turbine will rotate, how it is electrical current will produce mean. That is again the principle of electromagnetic induction. Induce, that is electric generator principle, that is different. But here only thing is we'll study how a turbine can be rotated, how the nuclear energy produced, and what is the working of nuclear reactor, we'll see. So this is what briefly the whole answer of the nuclear or this question. Then we'll see what points you should write in your answer sheet. What are the points we need to write and how we need to express the answer on our sheet. So let us look into that. First, principle. Principle is what? Principle. What is principle mean? Principle is basically nuclear fission reaction will be takes place. But nuclear, there is a continuous reaction will be takes place, and that too in terms of geometric progressions. That means each and every step, number of fissions reaction, rate of reaction increases. Rate of reaction will be increased. That means every step, reaction, number of reactions which are getting is increases. So that is uncontrolled chain reaction, we call it. Uncontrolled chain reaction. But for the nuclear reactor, we need to get a constant rate of energy. Constant rate of energy we require from fission reaction. That means we need to control the chain reaction. We need to control the chain reaction. Such type of chain reaction only we can use in the nuclear reactor to develop electricity or power. So principle is, it is based on controlled chain reaction. It is based on controlled chain reaction. Okay. Next, there are different parts of nuclear reactor will be present, or we can say what is nuclear reactor basically. Nuclear reactor. It is used to convert nuclear energy into electrical energy, or it is used to produce electrical power. Electrical power. Then now we'll see the different parts of nuclear reactor. So parts of reactors. Nuclear reactor. What are different parts we have? So basically nuclear reactor, I told just now, it works on the principle of controlled chain reaction. How the reaction can be controlled. And nuclear fission reaction takes place in the nuclear reactor. So nuclear fission reaction takes place means, should we have some fuel elements or should I have some radioactive substances? So fuel elements should be present. What are the fuels we are using in the nuclear reactor? And how we can control the reaction. And during nuclear fission, there is an emission of some neutrons will get. Emission of neutrons will come. And these neutrons only will get the next nuclear fissions. But the emission of neutrons during the nuclear fissions are fast neutrons, are fast neutron. But to get the nuclear fission, we required a slow neutron. We required a slow neutron. So that means in nuclear reactor, the fast neutrons should be slowed down. Fast neutrons should be slowed down. That can be how we can done that one. And next one is nuclear reactor, the heat energy generated due to the nuclear fission energy, and this heat will be used to used or to decrease that coolant will be used, and these coolants are used to develop some steam, especially for water. So steam will allow to fall on the turbines, correct? So that is coolants. And during nuclear reaction, there is a dangerous rays like gamma rays can also releases. So to avoid that effect of gamma rays, very dangerous health-wise. So there is a protecting shield will use around the nuclear reactor. There is a thick wall of protecting shield will use to protect from that dangerous electromagnetic radiation or gamma radiation we call. So these are different parts, like first part is fuel. How do we control the reaction? How we fast neutron to slow down, and how we protect us from the dangerous radiations. So these are different parts. So one by one we'll see now. First one is fuel rods. Fuel rods. So generally in nuclear reactor, enriched uranium, that is uranium 92-235, used as fuel. Used as fuel. That means uranium undergoes nuclear fission reactions, and that will give the nuclear energy from that. And so that means this is uranium act as a fuel elements or fuel rods. Generally that uranium rods are in the shape of cylindrical shape that will be present at the core of the nuclear reactor, at core of the nuclear reactor. Now after the fuel rod, there are moderator. What is moderator means? Just now I told, during nuclear fission reaction, the emission of neutrons are fast neutron. But to get the nuclear fission, when bombarded with a neutron, we required a slow neutron. We required a slow neutron. So these moderator are some material which are used to slow down the fast moving neutrons. Slow down the fast moving neutrons. So moderator are the materials used to slow down the fast moving neutrons. Fast moving neutrons are the material used to slow down the fast moving neutrons. Example which are used to slow down the neutrons means these example we can use heavy water as moderator or graphite as moderator you can use. What they will do moderator in graphite and heavy water means they whenever this neutron fast moving neutrons are passed through this moderator, so they absorb that energy from the fast moving neutrons. So the energy will decrease automatically. Fast, that is speed of the neutron will be decreases. So this is heavy water and graphite are used as a moderator to slow down the fast moving neutrons. Next, control rods. Control rods. Control rods. What is control rods means? Same, just now I told it is used to controlled chain reaction. It is based on controlled chain reaction, right? So how we can control the chain reaction? Means in every nuclear fission, there are more than two neutron, more than two neutrons will be produced as a fast neutrons. But to continue the nuclear reaction, only one neutron is required, because to continue the controlled chain reaction, we required one neutron only. So out of many, so one neutron only we required. Remaining neutrons should be controlled. So how it will be controlled means, this controlled rods, by using control rods, we can control that reaction. That means by absorbing this, some absorbing neutron absorbing material are used as a control rods. Neutron absorbing material used as a control rods to control the chain reaction. So generally, what are this? Neutron absorbing material are used as control rods to control chain reaction. Chain reaction in nuclear reactor. Example, we can see the boron and cadmium rods. Boron or cadmium rods are used as control rods. Boron or cadmium rod are used as a control rods. They can absorb the fast moving neutrons except one. So that automatically reaction will be controlled. This is control rods. So fuel rods, moderator and control rods. So finally there is a one concrete wall will be made around the nuclear reactor. Why a thick concrete wall will use? Means during nuclear reaction, there is a dangerous human being health affected rays, that is electromagnetic radiation or gamma rays will be produced. As these gamma rays will be fall on human beings, means those who are working around the nuclear reactor or those that place, so that will be affect the health. So to reduce that, a thick concrete walls like 10 to 15 meter thickness, 10 to 15 meter thickness walls will be made around the nuclear reactor, and it will act like protecting shield. Protective shield, like there is shielding. We are doing a shield around the nuclear reactor, which can be protected us from dangerous electromagnetic radiation. Clear? So that is protecting shield, we call protective shielding. It is protect. It is protect from gamma rays. Gamma rays. So generally, gamma rays. A thick concrete walls 10 to 15 meter. A thick concrete wall are made around reactor. Around reactor to protect us from gamma rays. So this is, it is protected from or protect from gamma rays. A thick concrete walls of 10 to 15 meter thickness are made around the reactor to protect from gamma rays, or protecting shield we call. So these are step-by-step principle. Nuclear reactor, parts of reactor is fuel rods, moderator, control rod, protective shield. These are the parts. Clear now? Now the last part of the question is its working with the need diagram. So with the diagram, we need to explain the working. Simple. Clear? So we'll see the working also. So everybody understood what is the principle and parts of the nuclear reactor? Simple, only theoretical question it is. So once you twice, if you go through the answer easily, you can write down. Clear? So now I will explain the remaining part, that is working of nuclear reactor. We'll see now. So generally nuclear reactor diagram you see. This is core of the nuclear reactor. Here control rods will be used, and this is called turbine, and this is core, and these two are control rods, and here fuel will be present in core. Fuel rods in terms of cylindrical shape will be present. So this is basic schematic diagram of nuclear reactor. Okay. So now explanation. What is the explanation? Explanation of this working. We'll see what is the explanation of working. See. So in generally, the fuel rod present in the core of the nuclear reactor as a cylindrical shape. That is, uranium rods are present in the core of the nuclear reactor. Now, how it is explained that working means simple. First, to start the nuclear fission reaction. To start the nuclear fission reaction. What happens? Nuclear reaction means first fuel rods. So to start the nuclear fission reaction in the reactor, these control rods will be pulled. Control rods will be pulled, and one neutron will strike the uranium nucleus like this. One neutron. If there is a uranium rods are there, right? So one of the uranium nucleus, there is a one neutron will be strike like this. One neutron will be strike like this. And after striking this, what happens? Nuclear fission reaction will be takes place. Nuclear fission reaction will be takes place. And due to this nuclear fission reaction, some nuclear energy will produce. Along with, there are approximately 3 neutrons will be released. 3 neutrons will be released like this. 3 neutrons will come. Okay. So as these 3 neutrons are released, and these 3 neutrons are fast moving neutrons. Fast moving neutrons. So, but we required. So if this left like this, there is a possibility of these 3 neutrons will go and strike with 3 more uranium nucleus. 3 more uranium nucleus. For like this, you see. Here also one uranium nucleus it strike, and here also one uranium nucleus strike, and here also one uranium nucleus will strike. So what will get? 3 more uranium nucleus will get in. Sorry, 3 more nuclear reaction will be get in the second step. In this way, what happened? Again, 3R here, 3R will get like this. Again, third step, 9 nuclear reaction will get. This type of reaction we call uncontrolled. And this type of reaction energy cannot be used to produce electricity. But our nuclear reactor used to control reaction. So how we can control means, you see here, look. So as I said, one neutron is strike with the uranium nucleus present in fuel rods, and it will emit 3 neutrons. Let us consider. These are fast neutrons. These are fast neutrons. Out of these fast 3 neutrons, 2 neutrons will be absorbed by neutron absorbing material. Neutron absorbing material called control rods. I told control rods like what are boron and cadmium rod will use, right? So these neutron absorbing material, out of these 3, 2 of them they will absorb, and 1 will be left. And this one also fast moving neutron only. But to get the nuclear fission, we required slow neutron. So for that, this fast neutron will allow to pass through the moderator. Allowed to pass through the moderator. And this moderator will absorb the energy, not neutron. Neutron ka energy absorb karega. So energy of neutron will be absorbed by the moderator elements, and the energy of neutron will be decreases. So that means energy decrease means obviously the neutron becomes slowed down. And this slowed down neutron will strike on one more uranium nucleus from the fuel rod, and will get furtherly again 3 neutrons will get. And the same procedure, again 3 more neutrons we got. From these, 2 of them will be absorbed by control rods. And again, third one is passes to the moderator to slow down it. And again, this is participate the next nuclear fission like this. So continuously, every time one uranium fission only we are getting 1, 1, 1. So that means constant rate of reaction we are getting. Constant rate of reaction we are getting. So in this way, whatever the energy in each nuclear fission is releasing, this is generally in the form of heat. So that will use, this heat energy will use to coolants, supply to the coolant material like air, water, carbon dioxide, CO2, like this material used as a coolant. So this coolants, this heat energy is supplied to the coolants, and that coolant will heat up the water. And that means it will produce a steam, and the steam is allowed to fall on the turbines, and that will finally produce the electric power. Brief explanation. So that means how we need to express. So the points you see here, this is no need to draw this diagram, but still I explain how it is happening in the reactor. You see, working how to explain here. Working. A slow neutron strike the uranium, enriched uranium, uranium 92-235, it strike the uranium and produce nuclear fission reaction, nuclear fission. And this nuclear fission, uranium in fission along with energy or nuclear energy, nuclear energy, 3 more neutrons are emitted. 3 more neutrons are emitted. Clear? A slow neutron strike the uranium and produce nuclear fission. In fission, along with nuclear energy, 3 more neutrons are emitted. And these are fast neutrons we call. Okay? So we can say, if you want, you can write, and these are fast neutrons. Okay. So next step, what you have to write? These fast neutrons are allowed to through moderator. Moderator, what will do? They will slow down the neutrons. They will slow down the neutron. So moderator, and it will be slowing down or slowed down neutron. Okay. And this slowed down neutrons will, out of these 3 neutrons, 2 neutrons will absorbed by control rods. Control rods. By using controlled rods, that means generally in nuclear reactor, control rods are in and out, they are moving. In and out, they will move like this. In, out, in, out. So due to this inward and outward motion of these control rods, two of the neutron can be absorbed. So by using control rods, neutrons can be absorbed. Neutrons can be absorbed. Clear? Then finally, nuclear energy is used to generate steam by supplying to water. By supplying to water, and this steam is allowed to fall on turbine. On turbine in order to produce power. In order to produce electric power or power, you can write, not a problem. Clear? So this is the, within 3/4 line, you can write the brief working of. Simple. As slow neutrons strike the enriched uranium and produce the nuclear fission. In fission, along with the nuclear energy, 3 more neutrons are emitted, and these are fast neutrons. These fast neutrons are allowed through moderator, and it will slow down neutrons. And it will slow down the neutrons. By using control rod, neutron can be absorbed. Neutron can be absorbed. That means control rod, by using control rod, we can control the reaction. Nuclear energy is used to generate the steam by supplying to water, and this steam is allowed to fall on the turbine in order to produce the power. So in these lines, if you write in your exam, so obviously you complete the answer. First, the elements of the reactor, that means parts of the reactor, and thereafter the working of the reactor. Clear now? In between, just I told that coolants also you add. Coolant are the material to use to absorb the heat energy generated during the nuclear fission. This much you add. Coolants are the material used to absorb the heat energy generated during the nuclear reaction or nuclear fission reaction. Generally, water or air are used as a coolants. Clear? So this is up the LAQ we have from nuclei chapter. Clear now? Everybody understood? So up to here we covered all the LAQs from 3 chapters. From waves, from current electricity, from nuclei chapter, which are very, very important for your exam. Okay. So mainly I'm covering because for a short period of time, you need to focus to score more marks. So I am focusing which are very important and very theoretical portion. Instead of numerical part, we are going with the theoretical, which are the question which are more important, and theoretical part that I explain. And even calculation part is there in Wheatstone bridge. That also simple calculation, I explained it. And this is purely theoretical question. So if you go through 2-3 times, automatically you know the answer. Is it clear now? Okay. टाइम क्या हो रहा है? नहीं, pause कर दो. Yeah, see. So that is what we have discussed, the nuclear reactor working and explanation. Along with the nuclear reactor, sometime they will ask one numerical question. Most probably one important numerical question related to that is here. If 1 microgram of uranium, 1 microgram of uranium is completely destroyed in atom bomb, how much energy will produce? How much energy will produce? That means in 1 microgram of uranium is completely destroyed. That means completely converted into energy. Then how much equivalent energy will produce per 1 microgram of uranium? Simple. As from Einstein energy equivalent equation, Einstein energy equivalent equation, simple question it is. So from this question, I can say mass is given 1 microgram they given. That is 1 into 10 to the power of minus 6 gram. And that is converted into kilogram, means 10 to the power of minus 6, and gram is converted into kilogram. That means again multiply with 10 to the power of minus 3, converted into kg. That is indirectly we can say the mass is given 1 into 10 to the power of minus 9 kilogram. Okay. And the energy equation, we know that E is equal to mc square. E is equal to mc square, where m is the amount of mass which is destroyed due to any reaction, and c is the speed of light in vacuum. And from this, m is given 1 into 10 to the power of 9 kilogram, and c we know speed of light, that is 3 into 10 to the power of 8 meter per second. If I use this one, so directly I can write energy produced will be mc square, correct? M is how much? 1 into 10 to the power of minus 9. Minus 9. Minus 9 into C is 3 into 10 to the power of 8 whole square. Correct? This is obviously 10 to the power of minus 9, and 3 become 9, and 10 to the power of 8 becomes 16, because we are square we are doing. So 10 to the power of minus 9, 10 to the power of plus 16. So if we'll cancel out, will remain will be 10 to the power of plus 7 will be remain from here. And the answer is 9 into 10 to the power of 7 joule. This is answer. 9 into 10 to the power of 7 joule is the answer. Simple. mc square we have to use. Mass is 1 microgram is given. And this is sometime 1 milligram they will give. 1 milligram. 1 milligram is given. Simple. In this one, 10 to the power of minus 6 place, we have to write minus 3. That's it. So here minus 3, again here minus 3 will come. So here in the answer, it will come minus 6. So minus 6 is cancelled. Here 10 to the power of 10 will come. 9 into 10 to the power of 10 joule. Is it clear? So 1 milligram or 1 microgram. Only milli or micro में difference है, but बाकी का procedure में कोई फर्क नहीं पड़ता. So procedure as it is same. Is it clear? Clear now? So this is the numerical question attached with the what do you call nuclei chapter. So from this, all the new LAQs which are important we have covered. Now we'll proceed to start SAQs, short answer questions. Short answer questions. What are short answer questions mean? Mainly from different chapters. SAQs will come. So first we'll begin with semiconductor devices. Semiconductor devices. From this, what are very important topic from which SAQs can become, will cover now. Okay. From semiconductor chapter, will one of the SAQ topic will going to cover now. Okay. See now. Semiconductor chapters. Okay. SAQ will come, mainly SAQs and VSAQs will come, but first we'll study what SAQ topics. Okay. See, first main important question SAQ is, first the question I'm writing, you see, what is half wave rectifier? And explain it. Rectification. What is rectification and what is, and explain half wave rectifier. Right? See here. Question is, what is rectifier and explain half wave rectifier. What is rectifier and explain half wave rectifier. So basically, what is rectifier? In that, what is half wave rectifier and what is, how it convert half wave rectifier? We'll see now. Basically, rectifier. Rectifier is, we have two types of currents. One is half wave one is alternating current. That is, every time interval after direction of current will be interchange. That is alternating current or alternating EMF. Every fixed interval of time, the current or voltage direction will be interchanges. That is called alternating current. Another current we call, or other EMF we call DC, direct. Direct current means direction of current is fixed. Direction of current is fixed and magnitude also fixed. Direction and magnitude both are fixed. That is called direct current we call. So we two currents we have. One is alternating current, other one is direct current. So wherever situation we required to convert alternating current into direct current. Alternating current into direct current. That is AC into DC. To convert, there is a device called rectifier we'll use to convert AC into DC. AC into DC, whether AC current or voltage, or that convert into DC current or voltage. So rectifier basically it is what? Convert it. It is used to convert AC into DC current or EMF or voltage. Okay. In this one, especially we are discussing half wave rectifier. What is half wave rectifier means? Rectifier basically convert AC into DC. But half wave rectifier do what means? Simple, by the name itself we can say half wave. Half of the AC input is converted into DC output. Only input, whatever the signal we are giving input, in that half of the input will be converted into output DC. Half of the AC input is converted into output DC. That is half wave rectifier is, it converts only half of AC input into DC output. Half of AC input into DC output. That's the reason we call half only it is converting. That's the reason half wave rectifier. Basically, rectifier is converting AC into DC, but half only it is converting. That's the reason half wave rectifier. Okay. So how it is convert, we'll see circuit diagram and that working of half wave rectifier also we'll see now. So basically in half wave rectifier, by using a junction diode, by using a PN junction diode, one of the application of the PN junction diode is a rectifier. So by using a PN junction diode, one we can convert AC into DC by using a rectifier device. So in half wave rectifier, because only half of the input is converting, so only one PN junction diode will be used in the half wave rectifier. We'll see circuit diagram you see here. This is input. Here one transformer will be used. And here one diode will be used. And the final it is output will given to load resistor. Generally RL we call, this is output. From here we'll take the output and here it will call input. Okay, this is P type semiconductor, here N type semiconductor is there. So this is half wave rectifier diagram. Generally, the input which we are supplying, the input voltage or current we are supplied like this. Plus, minus, plus, minus, plus, minus, plus, minus. This is input we are supplying to half wave rectifier. Okay. Then how it will convert into output? Output means, look here, the circuit diagram is, this is input source, transformer and diode, and output RL, load resistor, output will take from there. So the working will be basically, when input, in the input, when positive cycle is enter, positive half cycle is enter here. When the positive half cycle pass into the rectifier, then the diode which is there in the rectifier will set to be in a forward bias. Set to be in forward bias. We know that diode in forward bias allows the current or it allows the output. When diode is in reverse bias, it will not allow the output. Simple. Diode is in forward bias. That means it allows the output. Diode is in reverse bias. It will not allow the output. And when positive terminal is enter into the rectifier, then this positive terminal is entered, then diode will be set to be in a forward bias. Then this diode will allow the output so that we can collect the output from load resistor. We can collect the output from load resistor. So in this way, we will get the output like this, you see. Output. When the positive terminal is enter into rectifier, the diode is set to be in forward bias and it allows the output so that we can collect the output from load resistor and output will get like this. Plus, we got it, output. Plus is entered and diode is allowed and we got the output as plus. But now, when this negative half cycle is enter, when this negative half cycle is enter here, then the diode will be, terminals of the diode will be reverses because negative is enter. So terminals of the diode reverses mean the diode is set to be in reverse bias. And I told just now, when diode is in reverse bias, it will not allow any current or EMF. That means it not allows the output. So that means from the load resistor, we won't get any output. So empty, we won't get any output. No output. Okay, empty. Then again, this positive cycle is entered. Next positive cycle, next half of the positive cycle is entered in rectifier. Then diode again terminals are reverse. That is again it come to forward bias. And forward bias, it allows the current or it will get the output from load resistor. So again we'll get a output. So in between one positive, next positive gap is there. That gap is came from the negative cycle that is not allowed. See, that is only positive converted, negative obstructed. Again, next positive allowed, and again negative will be obstructed. That means only half is converting. Remaining half is stopping. That's the reason it is called half wave rectifier. Next also, it will come like this. Negative cycle is enter, again absent. Again, positive cycle will come, like so on, it will come alternatively. Only positive is allowing, negative is obstructing. That is only half is allowing, remaining half is stopping. That's the reason it is called half wave rectifier. So whatever I said that you need to write in the words, what you have to write, you see, look here, simple, working. When positive half cycle enters into a rectifier, the diode is said to be in forward bias and allows current and we collect output from RL, load resistor we call. Clear? Next, same, everything is same. Only thing is here it is negative half cycle and it is become reverse bias. That's it. So similarly, when negative half cycle enters into rectifier, the diode is said to be in reverse bias and it will not allows current. So we cannot get output from RL as shown. That's it. It's enough. Simple. Once again, I'll explain. You see, first you need to write what is rectifier definition. AC convert into DC. Half wave rectifier means half of the AC convert into DC output. The circuit diagram, input, transformer, diode, and this will be output, load resistor. This is input signal we are supplying, and which we are getting output signal from here. The explanation is when the positive cycle is enter, positive half cycle is enter into rectifier, the diode is set to be in forward bias and allows the current, and we collect output from RL. And when negative half cycle is enters into a rectifier, the diode is set to be reverse bias. It will not allow the current, and so we cannot get the output from RL. So like this, as shown, one after other, negatives are stopped, positives are allowing. So that's the reason. Full you are giving input, but only half we are getting output. Full you are giving input, but output we are getting only half. That's the reason it is half wave rectifier. Half wave rectifier. Clear now? Similar to this, there is a full wave rectifier is there that we will continue tomorrow. Full wave rectifier is also there. Very similar. The working and the diagrams little bit different. One more diode will be going to be added there, but so one central tap key also will be there, but remaining procedure will be same. Here half is converting there, full is convert. That's it. Clear now? It's one of the important SAQ from semiconductors. Clear now? Okay. Thank you.